Kansas, January 2010. After a 10-day stretch of record lows, which included temperatures of nearly 10 below zero, the forecast for today was 44 degrees and sunny, which was as highly anticipated as any first day of spring has ever been. The reality, high of around 35 with dense fog for most of the day. So dense that when first seen, nearly everybody thought it was snowing. Why do I mention this? I know some of you might think nothing of a 35-degree day in January, but that's not the point. The point is that to illustrate how difficult it is to forecast the weather accurately in a 10-day span. I know every one of you out there has at one time or another cursed your weatherman over being wrong. Now, imagine how accurately we can measure just the temperature, not to mention solar levels or solar radiation from 1,000 to 100 years ago, much less predict what these levels will be 20 years or 100 years or 1,000 years in the future. That's right, I'm talking about global warming, or the more currently accepted politically correct term, climate change. Basically, global warming is when the average temp of the Earth increases. Climate change is now used because we have to account for other factors, including average temps possibly decreasing. It is accepted scientific fact that the Earth's climate has changed drastically in geological record, but if we look at the temperature records over the last 1,000 years, we do know that the northern hemisphere experienced slight cooling during the 15th to the 19th century. The drop of less than 1 degree Celsius caused what the scientific community calls the Little Ice Age. The Little Ice Age has been attributed to be the cause of famine in Europe, and the Viking colonies in Greenland were perished. Around the end of the Little Ice Age, which was in the late 19th century, the average temperature began to steadily increase, regaining approximately 1 degree Celsius in that 100-year span. In a smaller segment from 1940 to 1945, the average temperature rose approximately half a degree Celsius, but in the next 25 years after that, the trend was to cooling. The current trend began in the 1970s and has been warming about half a degree Celsius. Between 1990 and the year 2000, we saw another large bump of average temperature of about 0.6 of a degree Celsius, and according to the historical records, the years 1998 and 2005 were the two hottest years in the last 1,000. Well, what causes this? Your first answer might be to say that it's caused by humans. Obviously, the last 100 years of humankind's industrial age has caused significant damage to the environment. That's easy to believe until you look at the facts of what really causes climate change. One of the main factors of climate change is the level of solar radiation. According to NASA, since 1970, the sun's radiation has been increasing by 0.5% per decade, mirroring any temperature increases. Astrophysicists, who are people who track things like solar cycles, point out that the solar cycle and average temperature changes coincide. Another main factor of climate change is the makeup of the Earth's atmosphere. The main component of the atmosphere that we are concerned with here is carbon dioxide and other greenhouse gases in the atmosphere which can absorb infrared energy. Carbon dioxide in the atmosphere was assumed to cause the Earth to retain more heat energy, which would cause an increase in temperature. However, the scientific community is not in agreement with this function of carbon dioxide. The converse argument is that more carbon dioxide in the atmosphere causes less heat energy from the sun to enter the atmosphere, which would actually cause cooling. As you can see from the slide, the model used to predict greenhouse warming in 1979 was horribly inaccurate. There is also the scientific argument that more CO2 in the atmosphere is actually a good thing. Why is that, you might ask? Well, it's because plants and plant life feed on carbon dioxide. Animal life feeds on plant life, and human life feeds on animal and plant life. The industrial era could actually bring around some of the lushest eras in the Earth's history based on the increase in plant food. So what happens when the climate changes on the Earth? We already know about the Ice Age and the Little Ice Age, so we know that melting ice caps and sea levels rising are a possibility. Famine, disease, and species extinction are all legitimate possibilities. The real question, is this normal? Just Mother Nature going about her business? Or has this been caused by humans and their reckless use of all available energy and fossil fuels? Oh, and one more thing about Kansas. We used to have glaciers here around 600,000 years ago, and they were around 500 feet thick. I wonder what happened to them. So what is the human race to do? Maybe launch a frantic effort to reduce CO2 emissions? In the words of Dr. S. Fred Singer, who is an atmospheric physicist at George Mason University and the founder of the Science and Environmental Policy Project, he says, well, the question is what you mean by doing something. I'm not a great believer in buying insurance if the risks are small and the premiums are high. Nobody in his right mind would do that. But this is the case here. We're being asked to pay an insurance policy against a risk that is not very small, if at all, and pay a very high premium. We're being asked to reduce energy use, not just by a few percent, but, according to the Kyoto Protocol, by about 35% within 10 years. This means giving up 1/3 of all energy use, using 1/3 less electricity, throwing out 1/3 of all cars perhaps. It would be a huge dislocation of our economy, and it would hit people very hard, particularly people who can least afford it. For what? All the Kyoto Protocol would do is slightly reduce the current rate of increase of carbon dioxide. And in fact, the UN Science Advisory Group has published their results. And they clearly show that the Kyoto Protocol would reduce, if it went into effect and were punctiliously observed by all the countries that have to observe it, by the year 2050, about 50 years from now, it would reduce the calculated temperature increase by 0.05 degrees centigrade. That amount is not even measurable. So this is what you're being asked to buy. Well, we at the Earnhardt Group are not proponents of popular global warming or climate change theories. We do, however, recognize the need to identify alternative energy sources and considerate usage of our current resources. To achieve the state of culture change required to bring this mindset to the forefront of society, we propose the following strategy. The financial impact of alternative energies and energy conservation is currently being underemphasized. The environmental movement is currently geared towards the save the fill in the blank, whether it's the rainforest, rabbits, lakes, whatever. Most of the advertising is geared towards devoted to saving something that, quite frankly, doesn't matter to the majority of people. The key to advertising or campaigning of any sort is to find out how many people who were not previously disposed to buy your product that you can convince to buy it. The vast majority of people who will respond to Save the Rainforest type advertising will be those who are already predisposed to respond to it anyway. What the environmental movement must do is illustrate the financial implications of energy conservation and identifying future energy sources. This is not only the most logical reason to adopt alternative energies, but it will reach the most people in a way that will cause them to take action. Recently, there have been more advertising related to energy conservation, such as the benefits of changing windows or using compact fluorescent lighting, but the larger issue of identifying alternative energy sources is still largely ignored. Forget for a moment the debate on the use of oil and fossil fuels. The country or company that discovers and makes viable even a partial replacement for these fossil fuels will control world markets for decades, much like the Middle East, which is very oil-rich, does now. The United States must lead the world's energy revolution into the 21st century and beyond that, not for the health of the environment, but for the health of the country and its economy, or it will be destined to fail like so many world powers that have come before it.